Neil deGrasse Tyson shouted, confirming the most puzzling and terrifying discovery made by Voyager in the past decade. In a shocking revelation, renowned astrophysicist Neil deGrasse Tyson confirmed the discovery of 500 unknown objects discovered by Voyager 1. This astonishing information has sent shockwaves through the scientific community, sending researchers, scientists, and engineers into a state of disbelief and anxiety. Ever since the Voyager spacecraft sent this disturbing data from space, the scientific community has been unable to sleep and everyone has been walking in an atmosphere of tension. Voyager 1, launched in 1977 by the geniuses at the Johns Hopkins Jet Propulsion Laboratory, has been traveling the highways of space for nearly 5 decades, exploring areas that ground-based telescopes have failed to see. He made discoveries that left us speechless with shock. As the golden messenger to unexplored intergalactic territories, Voyager 1 has opened our eyes to the breathtaking wonders that exist in our universe. Recently, Neil deGrasse Tyson confirmed that Voyager had detected 500 unidentified objects peacefully gliding through space. The news shocked the scientific community, sending shockwaves through scientists as people began to study the data collected by Voyager 1. Something strange is happening on the horizon, and it has been difficult to solve the puzzle that has left even the best of scientists baffled. Since Neil deGrasse Tyson confirmed the discovery, various explanations have emerged in an attempt to paint a vivid picture that explains the mystery. If another spacecraft transmitted this kind of cryptic data, scientists might doubt its authenticity. But it was indeed Voyager 1, a space probe that has been plying the treacherous waters of space for nearly 50 years and has exceeded our expectations. Like a patient beating cancer, Voyager 1 has exceeded scientists' expected 3-year lifespan and spent more than 45 years in space making historic discoveries. What's most fascinating about this iconic story is that Voyager is writing this success story at a great distance from Earth. The last time scientists checked, the space probe was 23.2 billion miles from our planet, hurtling through space with no signs of slowing down anytime soon. The space probe travels at a speed of 36 times the Earth-Sun distance per year, researchers say. This is a difficult thing for scientists to accept, as it is natural to assume that a space probe's speed will decrease significantly over the length of its journey through space. Voyager 1 seemed destined to be an exception to this rule, and it has proven itself once again with its latest discoveries. It was like any other day for scientists when Voyager 1 dropped some exciting news on them. News that will stay with them for centuries. Voyager 1 had accidentally discovered mysterious objects traveling through space. The discovery was unplanned, which explains the initial confusion of astronomers when they reviewed data showing that about 500 unknown objects had appeared out of nowhere. One minute, we didn't know these objects existed, and the next, scientists are racking their brains to find answers to the riddles that nature has left in their hearts. Scientists are at an impasse, and there is only one culprit to blame: Voyager 1. Ironically, scientists also know that the solution to this mystery also rests on the heavy shoulders of the space probe. Initially, when news of this discovery spread, some scientists thought it was likely a mistake. They think that Voyager's age might catch up with it and therefore it might give us erroneous data. If we decide to go this route, this seems like a plausible explanation since Voyager 1 was launched in 1977. That represents nearly 5 decades of active service on behalf of humanity. It's only to be expected that the spacecraft and computers would get tired and start malfunctioning, reducing their responsibilities and sending poor quality information back to the ground team. As appealing as this story may seem, scientists have advised against going this route because it would be a slap in the face to Voyager's altruistic spirit. Despite the hostile and unpredictable environment of space, Voyager 1 continues to produce revealing data about our universe. Contrary to the hasty assumptions of skeptics, the space probe has maintained its longevity thanks to 2 redundant computer systems. Like its twin Voyager 2, Voyager 1 is equipped with 2 sets of control subsystems: the Flight Data System, FDS, and the Attitude and Articulation Control System, ACS. These are the secret sauce behind the spacecraft's relentless spirit as it maps space and makes discoveries. Redundancy has paved the way for seamless switching between systems and the ability to activate dormant IT components, preserving their lifespan. When Voyager 1 was being designed, engineers on Earth developed a plan to make the space probe as efficient as possible. This required the probe and its instruments to rely on hardwired logic. They were reluctant to take any risks in this area due to time and power budget constraints. The electrical engineers decided that the instruments should be developed using simplified systems based on hardware logic. As a result, Voyager's computer system consisted of 6 onboard computers organized as a distributed system with 3 pairs of dual redundancy. After overcoming this obstacle, scientists faced another major obstacle: system maintenance. This difficult task was overcome by developing a continuous power management plan. This is where things got complicated. Power management involves keeping Voyager's communication systems operational. This is a difficult task due to the limited power resources available on the space probe. It's like sending a hunter into the deep woods to hunt wild animals with only a set of knives. However, scientists have found a way around this problem by developing a number of measures to conserve and optimize energy consumption on Voyager. A prime example is the selective power-off of non-essential systems. Engineers are forced to make this difficult decision, using a systematic approach to identify and disable components or subsystems that are not essential to the spacecraft's primary mission objectives. This decision requires careful assessment of the balance between energy conservation and the spacecraft's scientific objectives. Also, we must remember that the decision to shut down these non-essential systems was not taken lightly. It was a calculated exercise that required careful assessment of the balance between energy conservation and the scientific objectives of the spacecraft. Whenever such a decision was made, everyone had to be on board. Engineers and scientists had to sit down together and assess the impact of shutting down specific systems on the quality and availability of scientific data. Emotions were not involved. These were purely fact-based business decisions. The team is motivated by the desire to maximize energy efficiency while maintaining the spacecraft's essential functionality so it can continue to gather essential information about our universe without interruption. Engineers and scientists don't want anything to get in the way of Voyager's quest to uncover the deepest secrets locked away in the hidden realms of space. Secrets that the universe has kept from us for centuries. However, selective power reduction isn't the only way NASA engineers can keep Voyager afloat and operating optimally in space. They have another ace up their sleeve: an adaptive power management strategy. As Voyager 1 moves farther from the Sun, the available solar power will decrease. Engineers have compensated for this growing threat by ensuring that the spacecraft adjusts its power consumption accordingly. This adaptive approach is a breakthrough for NASA engineers and scientists because it ensures that available energy resources are allocated efficiently to support vital exploration activities and transmit data back to Earth. The good news doesn't stop there, though. Technical advances and ongoing upgrades in power management have allowed engineers to improve and optimize the spacecraft's power systems over the years. These improvements include more efficient power distribution, improved battery charging methods, and advances in power regulation and control. The implementation of carefully considered power management strategies extended the operational life of Voyager 1, along with its twin, Voyager 2. This was a major victory for the scientific community and the world that supported it. The careful allocation and management of power resources gave Voyager 1 the power it needed to continue exploring the depths of the universe. This revelation reverberated through the corridors of scientific research with seismic force. Neil deGrasse Tyson's urgent declaration reverberated around the world, marking a decade of meticulous exploration by Voyager 1. Amid the vastness of interstellar space, a spacecraft has detected a most significant anomaly: 500 mysterious entities whose origins and purposes are shrouded in cosmic mystery, silently traversing the void. This unexpected encounter has sparked a frenzy of activity in the scientific community where sleepless nights have become the norm. Tensions are palpable as researchers, engineers, and theorists attempt to decipher the implications of Voyager's discovery. Faced with a reality where the known laws of physics appear to be breaking down, Voyager 1, a beacon of human ingenuity and perseverance, has defied expectations. Its instruments, meticulously engineered to withstand the rigors of space travel, are now transmitting data that surpasses conventional understanding. As the spacecraft continues its lonely journey through uncharted realms, it carries with it the hopes and fears of those bound to Earth. Each data transmission, each received signal sheds new light on the complexity of the universe, challenges preconceived ideas, and invites humanity to reconsider its place in the cosmos. In the wake of Voyager 1's unsettling discovery, theories abound and debate rages in academia. Was this a chance encounter with extraterrestrial intelligence, or perhaps a glimpse of previously unseen phenomena of cosmic proportions? The unanswered questions fuel a relentless quest for knowledge as scientists dissect reams of data and scrutinize telemetry reports for elusive clues.